Okay, let's look at the number 22 first, okay? Number 22, the question is, I'm trying to make it bigger, okay? Because bigger. Okay, number 22. A solid is generated when the region is in the first quadrant enclosed by the graph of y equals parenthesis x squared plus 1 closing parenthesis third power, and the line x equals 0, x equals 1, and the x-axis and the y-axis is revolved about the x-axis, right? They ask you which one of the ABCD here represent the volume is found by evaluating which of the following integrals. For this one, first thing is better you sketch a little bit first. Okay, let's sketch here. So you have generally just general sketch. Okay, you have like this one. This is the x. This is the y. And I'm trying to graph the function y equals to, I'll make it bigger, okay? X squared plus 1 to the third power, right? So we're trying to graph this numbers. And they also have what? X-axis. So they use x-axis, I use different color here. They use the x-axis as a part of the boundary. And then suppose from here to here, okay? This is 1. So this part as a boundary. And also they use what? Y-axis as a boundary. So this y, part of the y-axis will be boundary. And then they use this one. We can choose when x equals 0. X equals 0, 0 squared is 0, plus 1, 0, third power is 1. So that's here is 1. And then you can pick up another one. You make x equals 1. 1 squared is 1, plus 1 is 2. 2 to the third power is 8. So I assume, okay, I assume somewhere is 8. So they got at this point. And they said, what, this one made it by the x equals 1 as a vertical line, as a boundary there. And then we know x equals 1, the function here is 8. So we don't care how the graph goes, okay? It's general sketch like this. They don't care about the curve, how they go like this, right? So if you draw this one, you can see the region here is represented the original shape, right? As here, there's a graph of this, which is the curve, and then line of x equals 1, it's vertical one, and the x-axis and the y-axis, part of y-axis, part of x-axis. So this one make the original shape. And then what are they gonna do? They said this shape will be rotate about x-axis. So when this one rotate, for example, this is a 1, you rotate, you got what? Like this, just like this, okay? And this one, when you rotate, right, you go up 10, 8, go down 8 somewhere here. So you may go like this, like this. So you rotate, if you really draw this one also got a circle like this. So you can see this one made a volume. When this plate, the original region has the plate, you rotate about the x-axis, you will build up the volume. So when you got this volume here, how do you find the volume, right? How do you find the volume? I just leave not put some there, okay? So easier for you to see the whole picture there. So you think about that. we use this method. One of the method about the integration about the find the volume is called the disk methods. Okay, how the disk method works? You think about this. For example, this is anywhere x, right? And this is the x, this is the y, and this y will be equals to what? This one, y equals this one. So if this one rotates, what happens? When this one rotates, you will see, use your imagination, you will see a vertical circle there, and then with the radius of the y, right? Because they rotate. So you see, when this one rotates, they will make a circle like this. That's a vertical one, okay? So let's find that area first. The area equals what? Pi y squared, right? And then you make this disk a little bit with a certain thickness. So you will get what? It was a thickness, you time by dx. You see, you already have a circle, area is pi y squared, and then time by dx. So you got a small disk there. That's the volume of disk, because the base area times the height. The dx just equivalent to the height. So you can find out just like this one here. For example, you have a disk like this one here, right? This one is a y, so you have a pi y squared. That's the area. But if you time by dx, so you got another one like this. So with a certain thickness. So that's the height. So you get the volume. This is the volume of the small disk here. And then we're going to integration from x from 1, from 0 to 1, like here. And that's what we got, what? The overall volume from the original shape here rotate. So this is the volume now. And then we can simplify further. The pi is a constant, can be out of the integration, and the 0 and the 1, and the y squared, right? Y squared we know is, because y equals this already, so x squared plus 1/3 power. And the y squared, because this is the y, inside the brackets is y, and they got a squared, and then dx. And you can continue to simplify. You got a pi, integration from 0 to 1, and you're gonna have what? X squared plus 1, second power, third power and second power. Power of power, you timed it. You got 6, and then dx. So this will be the answer. So check the answer here we have. This one must be what? The 22 here must be the D, right? So that's why D is the answer here. Okay? Now, let's recall what we had beginning. So when we have this question, general way is general sketch first, and then try to illustrate what's the original area first. And then from there, you rotate. You get the area of the circle, which is pi y squared. And then time by dx, that will be volume of the small disk. That's why this method is called disk method. And then integration means add all those disks. So from 0 to 1, that's this one. After you got this, simply just plug in what's the y above, then simplify, you can get this one. Okay? So this is about number 22nd. Now let's go to the other one here. We code it as what? Number 12, okay? Number 12, we need to do is to get what? Integration here. Let's do integration here, okay? I put it a space here, okay? For number 12, I put it here. This one, generally we use what we call it as a U substitute. So this is U, we make a U, okay? We make a U equals what? Equals 1 plus x squared. okay? If you do that, you can see du will be the constant 1, derivative is 0, and the x squared derivative is 2x and the dx. And then we divide it by 2. So we divided it by 2 divided by 2. So we have x dx equals what? Equals du over 2. Now, when you have this, you see here, this is the x dx. So this integration you can write like this, yeah? This x dx together, I put it as what? Du over 2. And then you have a square root. 1 plus x squared, we put as a u. See that? You see? After we do the u substitute of this, u equals 1 plus x squared, the integration is much easier. Now we can simplify, because this is 1 over 2, we can take it out, constant, right? And then integration here is u to the half power. I use the power, okay? This is du. And then how do you do this integration? You gotta use what? We call it the power rule of the integration formula. So we can get what? We can get like this in here. We can get like 1/2, right? This one you can go by time by 1 over this power n. That's a 1/2 plus 1. And then the u with the exponent of u and the 1/2 plus 1 and the plus c. This is constant, integration constant, right? Okay, now we can continue simplify. This 1/2 is there, and this 1 over, this is 1 over 1 times by 2 times by 2. You will get 1 over 2 plus 2 over 2, right? And then the top part will be u on 3 over 2, because this 1 plus 2 is 3, 3 over 2. And then you have a du plus c. And then continue. This 2 times by this one will be 1, times this one will be 2, add together is 3, so it's 1/3. And then, they have integration here. Integration, u we can change back to this x now. So you have what? 1 plus x squared, and then 3/2 power du, right? So we can get what? Oh, no, we got this one here. So we can continue. Here we can do the integration now. So when you do this one, you already got the antiderivative now here already. So you have 1/2, this one will be 1/3, right? And this one, we change it back. 1, because from here to here, we already finished the integration. I also can say we finished the antiderivative. So you got this one out here. U equals what? X squared. U equals 1 plus x squared, and then 3/2 power, and then plus c. Oh, here, actually, this du is no more, because you finished the integration already, so no more du. So from here, after this one already no more du, because you finish your integration. And from here to here, just simplify. Keep simplify, okay? So if you continue work on this one, you will get the number 12 will be what? The a here, you see here? 1/3, 1 plus x squared to the 3/2 power plus c. So that's what this answer. For this part here, the key steps is here. This one. This is the key step, because u equals 1 plus x squared. That's the key step here. When you do this one, you will make it simplify, easy for you to change this format here. See here? After changing this format, you can do this integration by using power rule formula for integration. So you got this, and then you simplify, And the final answer is this. Okay? Now, let's go to the number 19 here. Number 19 here, the first thing first is this. This part a little bit complicated, right? So what we're gonna do is this here. We simplify this one first, okay? I show you how to simplify, huh? So we have like what? E to the 3lnx. Actually, this is the algebra, okay? The 3 is the power. You can put it on the top of the x here. So this one you can change to E ln(x) to the third power. Then E and the ln, okay, let me point out here. This E and this E and the ln, they are inverse function each other. So if you do that together, then we get x cubed. They cancel each other. You got x to the third power. So from here, you will get what? You will get integration x third plus E 3x and the parenthesis dx. This is much easier now. So from here, you can change it to 2, split them. X cubed dx and the plus and the E 3x and dx. And then from here, you can use the power rule. So 1 over 3 plus 1 and the x 3 plus 1 like this, right? And then this one now. This part here, we need to do is we use the u substitute, okay? We're gonna use the u substitute as u equals 3x. And then du will be equal to 3 dx. So the dx will be what? U over 3, du over 3. I'm going to substitute this one to here and here, okay? I'm using this one substitute to here, this one substitute to here. So you will see this one will be what the E, you will change the U, 3x equals U. And then dx will be what? Du over 3, right? And then continue. This is 1/4 x to the 4th power. Of course, you're going to plus c, yeah? Because eventually when you finish this, you're going to plus c. Yeah? So this one, you're going to have what? 1/3 is constant, take it out. U plus c like this, right? Because the integration of the natural exponent function, you're going to be just itself, right? So you got 1/4 x to the 4th and the plus 1/3 E, and then substitute this one back because u equals 3x. Eventually we're going to x as the variable, right? So 3x plus c. This is the answer here. Let's check which one will be the answer there, right? Which one will be the answer? Number 19 here, you see here, the D here is it 1/4 x/4 plus E 3x over 3 plus c. So this is the answer. D's answer. Okay, when you do this part here, you can see the key part is that we did the simplify. We did simplify here. That's the most important part here. Okay, that's actually the algebra. It's not calculus. Yeah, we use the property of the logarithm and the exponential and the log, natural exponential and the natural log, they inverse each other, cancel. So we got x cubed. And then you do this part, it's easier. And this one, we just do the u substitute here. This u substitute also very useful because this the exponent here is not only x, you have 3x there, right? So I have to change to one variable. So that's why we do the simplify, we got this one, okay? So if you have any questions, please let me know. Thank you, bye-bye.